Hi guys, Rehan Solomon here at Design Fusion. In this video, we'll be going over reverse engineering using Solid Edge 2021. You can see we have this 3D scan data here of a generic head, and we'll be creating a custom fit helmet for this gentleman, and we'll be aiming to make a skateboarding type of helmet today. So I'll be going over these commands that we have on the reverse engineering tab, starting with the align command. This lets you align the mesh bodies to the base coordinate system or a custom coordinate system that you created. So first you'll select your mesh body and accept the selection. Now you have four options. Use principal axes would be to use the coordinate system of the mesh body and align it to that of the base coordinate system. Then we have best fit bounding box, which automatically creates a box that contains your model. You would then go and place the coordinate system on a key point of that box, and then you can orient it in a certain way. You'll see here in the bottom the keys N for next, and then you can match it to the base coordinate system. The use custom bounding box is the same as the best fit one, except now you can create your own box containing the model, which is why it asks you to choose a plane, because you have to sketch out your own box, and then it's basically the same procedure as the best fit bounding box. Now geometry references allows you to select a key point anywhere on your mesh body, and it will place a coordinate system there, and then you can use that to align it to the base one. The delete mesh command we'll go over in a bit. You'll see me using this command when we start. So let's jump to the smooth mesh command. This lets you smoothen out any sharp edges or imperfections in the mesh body. And I'll go over an example here with you. So here you have the smoothing factor, and this basically decides how much the facets can move from their original position. So a higher percentage means the more movement is allowed. Iterations is just how many times the smoothing process is performed. So I'm using the maximum values for both, and just for demonstration purposes, I want to get you a clear idea of what this does. So I'm going to select the body and accept. And when I apply this, you don't notice the change right away unless I zoom in some areas and then undo and redo the command. If I zoom in on the mouth and undo and redo, you can see how the smooth command works. It's removing that deeper indent of the lips, taking out those sharper edges. Now the smooth mesh command also depends on the mesh size. So let's go to the remesh command to not only see how we can resize a mesh, but how this can impact the smooth mesh command as well. So you can see we have a pretty fine mesh here, and we're going to increase the mesh size to make it more coarse. You'll see this message here that says, by default, the minimum size is half of the target size, and the chordal tolerance is 10% of the target size. So we'll go ahead and use a target size of 10 millimeters, a minimum size of 5 millimeters, and a chordal tolerance of 1 millimeter. Now notice how the mesh is a lot more coarse than before. You see these bigger triangles. Now we'll go back to the smooth mesh command, and let's try this again with the same values. I'll go ahead and accept. Now this time you can really see the significant changes when the mesh is coarse. A lot of the sharp details are very smoothened out now. If you take a look at the nose, the mouth, the eye sockets, and even the ear, it really smoothens out all of those sharper edges. So I'll go ahead and exit out of this. So now onto the optimize command. It's always good practice to optimize your scan data. This will try to optimize the model and rectify any bad edges or faces that you have. You can see for us and the before and after are the same, so there were no real issues with this data. It didn't change anything. The geometry inspector is also a great tool to check out for any faults or small entities in the mesh body. Here you can enter in all your tolerances and then click go to perform all these checks. You can see we have no faults found in our mesh body, but if you did, they'd be listed here. And then you can click on heal body faults and it will try and repair those. This automatic identify regions command is more for data that has planar, cylindrical, or spherical areas. It won't really work well with what we have since this is more of an organic shape. But ideally, this would identify all the flat, cylindrical, or spherical areas and associate each with a certain color. So, for example, all the planar areas would be in red, there would be all the cylindrical areas in blue, and so on. And then you'd use the extract command, which would create surfaces for those regions. So it would create a flat surface on all the planar regions in that body, and so forth, and then you can trim and stitch all those surfaces together. The manual command here is basically to do what I just explained, but manually. I actually used this command in our previous video where I reverse engineered a kettlebell. I'll do a quick demonstration here. So you take your brush and you start capturing the area that you want to target. So I'll be going over the top of his head like this, since I want to capture this area to create a helmet for him. I don't need the rest. Now you'd go all the way around, but just for demonstration purposes, I'll stop here. And then I'll go to the fit command to capture this region I just created. I'm going to use a B-spline, and then you can see how it goes and captures this little surface that I created, the region I created. But since I already went over this in our previous video, this time I'd like to take a different route. I'm going to be using the delete mesh command. And since I don't need all of this area in the bottom and his face, really, it's going to be a bit more cleaner to use this method. It's going to be less crowded. Now for the fill holes command, let's say you had some holes like this in your mesh model. You can go to the fill holes command, select your mesh body and accept, and it will show you the holes that you can fill outlined in yellow. Now you can hold Control and select both the holes and then accept, and it'll fill those holes tangent to the surrounding edges. Now to start our process for the helmet, using the delete mesh command, you'll have 4 options. You can delete the entire body or face. You can use the brush, as you just saw me use to make those holes that we filled back in. You can use the fence, where anything inside this fence will be selected. So you see it takes everything that was inside the fence. And then you could use the box command. So first you'd create a box in 2D, and then you switch to the side, and then you can choose at the depth that you want to select. So to start, I'm going to delete the major regions I don't need using the fence option. So I'll get rid of this whole bottom area here, and then I'm going to get rid of 2 more areas here. Also get rid of the face, I won't need this area. And now I'm going to use the brush, and I'm going to start by outlining the area that I'll need. So I'm going to make my way around and then start filling in everything under this outline. So everything that's going to be in green is what I'm going to delete. And just to not bore you during this process, I'm going to jump to a model where my mesh is already prepared, where I already performed this action and deleted everything under the outline. So you can see here, this is the only area that I'll need to create my helmet. Now I'm going to use the fit command to create a B-spline with a 0.5 millimeter tolerance to create a surface over this mesh. Now the reason you need to do this as opposed to just using the mesh to then create a solid model is that it won't provide good results and surface finish. The mesh is just graphic data, so you may run into numerous issues when trying to modify this once you've made a solid body out of it. The B-spline surface will have proper data, so we can have good surface finish once we turn it into a solid body, and we'll also easily be able to modify and make changes to it without errors. So once I'm done with all the reverse engineering, I like to switch to the ordered paradigm. Surfacing can be a tedious task and it can involve a lot of going back and forth to edit features, so I like to have it history based. Now I'm going to bring in a part copy of the original scan data so we can use that for reference when we're creating the helmet. And I'll get a message here saying a design body cannot be found. That's fine, you just need to go in and edit the options and specify that it's a construction body. So once that's done, you click OK, and now our original scan data is shown. And now I'm going to use this as a reference for where I should trim all the excess regions of that B-spline we created. So now I'm going to create an extruded surface here that's going to intersect our B-spline. And using the curve command, I'm going to sketch out the area that I want to remove. So everything below the curve is going to be removed. And once done, I'm going to modify it from the control points here. Make sure I got a nice smooth curve, equally outlining the ear. Small touch-ups here and there. Now we're going to do a symmetrical extrude of this surface and make sure it completely intersects with the B-spline. Now using the trim command, I can now get rid of all the excess surface here we have at the bottom. And we'll hide that extrude command. Now you can see how it fits nicely over the head here, over our part copy. Next, we're going to offset the surface outwards by 6 millimeters to leave some room for some foam or some type of cushion for the helmet. You can see that's done. I'm going to hide the inside surface here, the trim. And now using the thicken command, I can finally create a solid design body. So you can see this is how you can use scan data, STL files and such to create now solid bodies out of it, and now that you can modify this and make it your own. Next, we want to create some holes for breathability and airflow. So I'm going to make an angled plane parallel to the front of the helmet to the best of my ability here. And now I'm going to create a sketch to a parallel to this plane that I just created and move it out in front of the helmet. And now I'm going to create two holes and then use the project command to project it onto the surface, where I could then do the normal cutout to create my two holes. Now I'm going to try to make some more aesthetic cutouts on the top for some more breathability. So I'm going to create another angled plane, this time somewhat similar, parallel to the top surface of the helmet. And then I'm going to create a sketch again on a parallel plane to the one we created and move it up above the helmet. Now I'm going to fast forward some of this sketching, but I want to pause here where I start to do a pattern of the sketch elements I just created. So this feature was not available in some other previous versions where you can actually pattern sketch elements while you're in the sketch environment. So you'll click on the rectangular pattern feature there. You'll select your sketch elements that you want to pattern. And then you go ahead and create your rectangle from the starting point of the pattern. And then you choose how many instances you want in the X and Y direction. And of course, you can also control the dimensions of the rectangle, and you're pretty much done. And you can click on that rectangle again to modify the pattern parameters there, to re-enter that as 1. And now the same process, we're just going to project this onto the top surface of the helmet and again do a normal cutout. Lastly, we're going to create some holes for some post-processing where they can use some pins to secure where the straps will go, and that's going to be used to fasten the helmet onto the user. Again, as we've been doing, we're just going to create some sketches and then project it onto the surface and perform a normal cutout. And here we have it, a custom made helmet. This can be 3D printed as well, depending on the size of the printer. And here we'll add some rounds to these outside edges for aesthetics. And that's it for the video. Thanks for watching.